What is a dimensional model? A dimensional model is a data structure technique optimized for data warehousing. The concept of this was developed by Ralph Kimball. So who is Ralph Kimball? Ralph Kimball founded the Kimball Group. Since 1980s, he was the data warehousing industry's top leader on a dimensional approach and trained 20,000 students. He co-authored all the books in the Toolkit series and finished his PhD in electrical engineering from Stanford University. According to Kimball, dimensional model is designed to read, analyze, summarize numeric information like value, balances, count, weights in data warehouse.
The accuracy of your dimensional modeling determines the success of your data warehouse implementation. It should determine your what, when, where, and how of your business process. But there are requirements for your data design. It is the act of putting together all the data structure where areas, every data structure is the group of data element. As you can see in this picture,
requirements to data design means gathering of requirements in a definition document. All the informations being gathered are put into package diagrams, which consists of metrics, dimensions, and hierarchies. This forms a logical data design, which results to dimensional data model.
Dimensional modeling basics has specific data to represent the business dimension. It also consists of data structure, which are called measurements or metrics. So we have this diagram at my left, which is called the automaker sales. So we can see at the bottom of the list are the measurements or the metrics that will be used to analyze this diagram. So the second one is what we call as the column headings. So the column headings consist of the categories or the hierarchies that will be used also to identify the diagram. So the third one are the attributes of each business dimensions. Now we can already identify those three types of data entities. The first one is the measurement and the metrics. The second one is the business dimension, and the third one is the attributes for each business dimension. There are tips for combining data into dimensional model. Tip number 1. Provide best data access. Tip number 2. Models should be optimized for queries and analysis. Tip number 3. Models should reveal the interaction between dimensions and fact tables. ER model or the entity relationship has a difference to dimensional model. As an entity relationship or ER model, I have one table for entity. As a dimensional model, I have one fact table for organization, and I can maximize understandability. I can minimize redundancy. I can optimize retrieval. Well, I can optimize update. There are several functions of case tools, or what we call as computer-aided software engineering tools. The first one is by creating logical schema and physical schema for target database management system. The second one is the ability to forward engineer model and by creating target schema for the target database management systems. So the third one is you can create fact tables, dimension tables, and establish the relationship between these two, and as a result, you can create a star schema model. So what is a star schema? So a star schema is a fundamental data technique for your data warehouse. You have a good grasp on your structure when you have the star schema model. You can easily understand it, and it is comfortable to work with. It easily answers the questions of whom, what, by whom, and to whom. So when a query is made against the data warehouse, the results of the query are produced by combining the dimension model and the fact table. So the joins of this is called the star schema. It is the result of the combination of this fact table and the dimension table. So there are three schema keys that we must always put in mind. The first one is the primary key. Each row in a dimension table is identified by a unique value of an attribute designated as the primary key of this dimension. So when you have a product dimension table, the primary key identifies each product uniquely. The second one is the surrogate key. The surrogate key is a system-generated sequence numbers with no built-in meanings. And then the last one, and the third one, is the foreign key. We must put in mind that primary key of each dimension table must be a foreign key of the fact table.